Hello everyone, this is Yashveen. Today I'm going to be solving paper 4 variant 1 May-June 2019 0625 physics. Question number 1. A rocket is stationary on the launch pad at time t is equal to 0. The rocket engines are switched on and exhaust gases are ejected from the nozzles of the engines. The rocket accelerates upwards. Figure 1.1 shows how the acceleration of the rocket varies between time 0 and time t. Alright, A, define acceleration. So we simply write the formula of acceleration over here, which is v minus u divided by t.
Part B, on figure 1.2, sketch a graph to show how the speed of the rocket varies between time is equals to 0 and time is equals to tf. Now, in the first part, it says a rocket is stationary on the launch pad at time t is equals to 0. The rocket engines are switched on and exhaust gases are ejected from the nozzles of the engines. The rocket accelerates upwards. Okay, so first it undergoes acceleration for some time, and then you see over here until this second the rocket clearly accelerates. At this second onwards, the acceleration is constant. So how do we represent this on the speed time graph? First of all, there's going to be an increasing gradient, and then after some time until time tf, it's going to be a straight positive gradient. Over here speed is increasing, over here the change in speed is constant.
C. Sometime later, the rocket is far from the Earth. The effect of Earth's gravity on the motion of the rocket is insignificant. As the rocket accelerates, its momentum increases. 1. State the principle of the conservation of momentum. Alright, so the principle is given that no external
Part 2. Explain how the principle of the conservation of momentum applies to the accelerating rocket and the exhaust gases. So a law of momentum is momentum before explosion and after explosion has to stay the same, and hence momentum of the gas would increase but in the opposite direction as to balance the change. So suppose if the rocket was moving to the right and the exhaust gases are being ejected on the left, so exhaust gases will have an increase in their momentum towards the left, but because the rocket has increase in its momentum towards the right. So that's the law of momentum. So I'll write rocket gains momentum, so momentum of gas increases too, but in the opposite direction. All right. Question number 2, figure 2.1 shows a sign that extends over a road. Okay. The mass of the sign is 3.4 into 10 to the power 3 kilograms. Part A, calculate the weight of the sign. So the formula is our weight will be equal to, mass is 3.4 into 10 to the power 3. G has a fixed value of 10. So our answer for weight is going to be 3.4 into 10 to the power 4 newtons. Don't forget mentioning the units. Part B, the weight of the sign X is at a horizontal distance of 1.8 meters from the center of the support post, and it produces a turning effect about point P. So there is a sign hanging over here, and then its weight acts downwards, of course, and it has a horizontal distance of 1.8 meters from here until the center of the post, support post. The distance is 1.8 meters. From here, support post will either gonna be moving clockwise or anti-clockwise. Point P is a horizontal distance of 1.3 meters from the center of the support post. Part 1, calculate the moment about P due to the weight of the sign. So you have to take the perpendicular distance between the point W and point P. So their distance is 1.8 meters minus 1.3 meters, which is 0.4 meters. So the formula for moment is force multiplied by perpendicular distance. So they're asking due to its weight of the post is, weight of the sign is, we calculated in part 1, which is 3.4 into 10 to the power 4 multiplied by distance, we just calculated 0.4 meters, and your answer will be 1.7 into 10 to the power 4 Newton meters. Part 2. A concrete block is positioned on the other side of the support post with its center of mass a horizontal distance of 70 centimeters from the center of the support post. State what is meant by center of mass. So center of mass is a point in an object where whole mass of it seems to act. The weight of the concrete block produces a moment about point P that exactly cancels the moment caused by the weight W. Calculate the weight of the concrete block. Whenever your question says about some point, by that they mean you have to take all the distances from that point. That is your turning point. So over here we are going to apply the law of moment, which is total clockwise moment is equal to total anti-clockwise moment. Alright, this sign will be making a clockwise moment, and we just calculated in part B, part 1, its moment about point P. So I'll be taking this over here, 1.7 into 10 to the power 4 is equals to total anti-clockwise movement. My concrete block will be moving anti-clockwise, so its weight is unknown to us, and that's what we have to calculate. W multiplied by the distance between the perpendicular distance between concrete block and the point P. So this is 1.3 meters plus 0.7 meters. 1.3 plus 0.7 meters, and it gives us 8.5 into 10 to the power 3 newtons. Part C, the concrete block is removed. Okay, the sign and support post rotate about point P in a clockwise direction. Of course, there's nothing to counter the clockwise moment. So of course, it's gonna move only in the clockwise direction. State and explain what happens to the moment about point P due to the weight of the sign as it rotates. Okay, so clockwise moment will of course increase, and as a result, perpendicular distance between center of weight of the sign and P will increase. So clockwise moment increases, and as a result, perpendicular distance between point P and center of the sign hanging. Question number 3. A cube of side 0.04 meters is floating in a container of liquid. Figure 3.1 shows that the surface of the liquid is 0.028 meters above the level of the bottom face of the cube. The pressure of the air above the cube exerts a force on the top face of the cube. The valve is closed. Part A, explain in terms of air molecules how the force due to the pressure of the air is produced. Okay, so I'll write air molecules collide with each other and with the walls of the container. When they collide with the walls of the container, they experience a rebound, the same momentum, but in opposite direction. And you know that force is equal to change in momentum divided by time taken. So within that time period, there is a change in momentum.
B. The density of the liquid in the container is 1500 kilograms per meter cube. Calculate 1. The pressure due to the liquid at a depth of 0.028 meters. Alright, so we have pressure is equal to density into gravity into height, which is the density given in the question is 1500 into gravity, which is 10, or acceleration due to gravity, into height, which is 0.028. And this gives us the answer as 420 pascals of pressure. 2. The force on the bottom face of the cube caused by the pressure due to the liquid. Alright, so we have the formula of force as pressure into area. So we have the pressure and we need to calculate the area. Since this is a cuboid, the base is supposed to be in the shape of a square, and the area of a square is side into side, which should be equal to 0.4 into 0.4. This is the area multiplied by the pressure, which is 420 in the previous answer, and this gives us a force of 0.67 newtons.
Part C. The valve is opened and the liquid is pumped into the container. The surface of the liquid rises a distance of 0.034 meters. The cube remains floating in the liquid with its bottom face 0.028 meters below the surface of the liquid. Calculate the work done on the cube by the force in B2. Okay, so formula for work done is equals to force multiplied by distance. They say that you have to calculate the work done by the force in part B2. 0.67, and the distance it traveled in the direction of the force is 0.034, which they mentioned on the top, and your answer will be 0.023 joules. But to suggest one reason why this is not an efficient method of lifting up a cube, because when you lift the cube, using this method, you are basically lifting water too, which is unwanted.
Question number 4. Gas of mass 0.23 grams is trapped in a cylinder by a piston. The gas is at atmospheric pressure which is 1 into 10 to the power of 5 pascals. Figure 4.1 shows the piston held in position by a catch. Alright, so the volume of the trapped gas is 1.9 into 10 to the power of -4 meter cube. An electrical heater is used to increase the temperature of the trapped gas by 550 degrees Celsius. A. The specific heat capacity of the gas is 0.72 joules per grams degree Celsius. 1. Calculate the energy required to increase the temperature of the trapped gas by 550 degrees Celsius. So we have the formula of specific heat capacity as energy divided by mass into change in temperature. And since here we need to find out energy, we'll multiply the specific heat capacity, which is 0.72, with the mass, which given in the question is 0.23 grams, into the change of temperature, and that is 550 degrees Celsius. So we have the answer as 91 joules. This is corrected to two significant figures, which is going to be the standard form of numerical answers in this paper. 2. The power of heater is 2.4 watts. 1. Calculate how long it takes for the heater to supply the energy calculated in A part 1. Alright. So we have the formula of time as energy divided by power. Alright, so we had energy as 91 joules over here, which is which is a rounded figure. So we'll be using, for calculation purpose, we'll be using the exact value of this product, the exact product of this multiplication, which is 91.08 divided by the power, which is 2.4 watts, and this gives us the answer as 38 seconds. Alright. 2. In practice, it takes much longer to increase the temperature of the gas by 550 degrees Celsius using the heater. Suggest one reason for this. So that could have been that the energy gained or the temperature gained is being lost to the environment, so it takes longer time to regain that energy or keep gaining it until the temperature reaches temperature change is 550 degrees Celsius. So this is
Part B, when the temperature of the gas has increased by 50 degrees Celsius, its pressure is 2.9 into 10 to the power of 5 pascals. Okay, so the pressure due to increase in temperature, I understand that the pressure increases too. The catch is then released, allowing the piston to move. As the piston moves, the temperature of the gas remains constant. Part 1, state and explain what happens to piston. So, though there is atmospheric pressure acting to the left on piston, when the internal pressure increases and it exceeds the atmospheric pressure which is acting outside on the piston, as a result, piston starts to move to the right, and this explains that a resultant force is acting to the right on the piston. So on right, piston starts moving to the right, thus a resultant force is acting to the right.
2. Determine the volume of the gas when the piston stops moving. Alright, so first we have initially we had the pressure as 2.9 into 10 to the power of 5 when the volume of the piston was 1.9 into 10 to the power of -4. So I'm using the formula P1V1 is equal to P2 and V2. So V2 should be equal to P1V1 divided by P2. And once the catch gets released, the final pressure should be equal to atmospheric pressure, and that is 1 into 10 to the power of 5, and this gives us the answer as 5.5 into 10 to the power of -4 meters cube. Question number 5. Liquids and gases are two states of matter. A. In boiling and evaporation, a liquid changes into gas. 1. State two ways in which boiling differs from evaporation. So boiling takes place throughout the liquid. However, evaporation only takes place at the surface, and boiling does not have a cooling effect.
Part 2, before injecting a patient, a doctor wipes a small amount of volatile liquid onto a patient's skin, explaining in terms of molecules how this procedure cools the patient's skin. So that's evaporation. When our skin gets rubbed with the volatile liquid, what basically is happening, all those molecules that possess higher energy will leave the surface of your skin, and those of low energy will be left behind. Thus, temperature decreases when they possess since they possess low energy, and that's how thermal energy is lost by your skin. Okay. Part B, gases can be compressed but liquids are incompressible. Explain in terms of molecules why liquids are incompressible. So comparatively, there's no space between liquid molecules as compared to gaseous molecules. And there are stronger intermolecular forces too, which lead to this property of liquids. Question number 6. Green light of frequency 5.7 into 10 to the power 14 Hz is traveling in air at a speed of 3 into 10 to the power 8 meters per second. The light is incident on the surface of a transparent solid. Figure 6.1 shows the wavefronts and the direction of travel of the light in the air. The light travels more slowly in the transparent solid. Explain in terms of the wavefronts why the light changes direction as it enters the solid. You may draw on figure 6.1 as part of your answer. Okay, so not all the wavefronts will be hitting the solid at the same time. All those part of wavefronts which are nearer to solid will be hitting the solid first, and all parts are going to hit the solid at different time intervals. So some parts of wavefronts hit the solid first, and they all hit the solid at different time intervals. And they say you may draw on figure 6.1 as part of your answers. This one over here, this one over here, and this one over here. These part of their own wavefronts will be hitting the solid first. So you may indicate circled one are hitting the solid first. And later on, the rest of the parts will be hitting the solid too, but they will be hitting at different time intervals. And this is the reason why the light will change its direction when it enters solid. Otherwise, it won't. It will travel straight in air.
B. The refractive index of the transparent solid is 1.31. The light is incident on the surface of the solid at an angle of incidence of 67 degrees Celsius. 67 degrees Celsius, wow. Of 67 degrees. Calculate the angle of refraction of the light in the solid. Alright, so we have the formula of refractive index as sine I over sine R. So since this is traveling, and I'm using this because the light is traveling from rarer medium, which is air, to a denser medium, that is the solid, and I'll have to shift it, that is sine R is equal to sine I divided by the refractive index. So we have it as sine 69 divided by 1.3, and we get the answer as 0.781. 708, and sine inverse of this value gives us the refractive index, the angle of refraction, which is 45 degrees Celsius. 45 degrees.
Part 2, determine the wavelength of the green light in the transparent solid. So there will be a decrease in the wavelength as soon as the light enters the solid. Firstly, we need to find the wavelength of the green light in the air. To find the wavelength, the formula is wavelength is equal to speed divided by frequency. Speed and frequency were given to us in the very beginning of the question, which are this is the frequency, this is the speed. So when you divide them, you'll get a wavelength of 5.3 into 10 to the power -7 meters. And now this is its original wavelength, and they were asking us to calculate the wavelength when it enters the transparent solid. And we know when it enters a denser material, the wavelength of light decreases. So this is its original wavelength when it was in air. So to calculate the wavelength of the light in solid, the formula is wavelength in solid is equals to original wavelength divided by its refractive index of the light. Alright, so now you have the original wavelength, and you also have the refractive index of the light from part 1. So the wavelength in solid is equals to 4 into 10 to the power -7 meters.
Question number 7. Figure 7.1 shows a circuit diagram that includes component X. A, state the name of component X. So this is a thermistor, and it's a component whose resistance increases once temperature decreases, so its resistance is inversely proportional to temperature. B. The electromotive force of the battery is E. The switch is closed. The potential difference across 30 ohms resistor is V30. The potential difference across 20 ohms resistor is V20. The potential difference across the component X is Vx. State an equation that relates Vx to 1 V30. So V30 over here is in parallel to X, and since these components are parallel to each other, both of them are supposed to have a potential difference of equal value, and so that means Vx is equal to V30. State an equation that relates Vx to E and V20. So if we subtract V20 from the total potential difference, this would give us the value of Vx and V30. So that means the equation which you can use over here is Vx is equal to E minus V20. C. The EMF of the battery is 6 volts and the resistance of component X is 15 ohms. Calculate 1. The total resistance of the circuit. So we have the parallel resistors as 15 into 30 divided by 15 plus 30, and this gives us the resistance of the parallel resistors plus 20, which is the resistor in series, and we get the answer as 30 ohms. 2. The ammeter reading. Alright, so current is equal to voltage over resistance. So the total voltage is 6 and the resistance is 30, and then we have the answer as 0.2 ammeters. D. The temperature of component X increases. State and explain what happens to the ammeter reading. So if the temperature of X increases, that is the thermistor, that should mean the resistance is decreasing, since resistance and temperature over here in thermistor are inversely proportional to each other. So if resistance of thermistor decreases, that means the total resistance also decreases, which in turn increases the current of the circuit, and that also means that the current reading in the ammeter increases. Since
Question number 8. A student turns the handle of an alternating current generator and the coil rotates. Figure 8.1 represents the structure of the AC generator. Part A. There is an alternating voltage output between the two terminals. Explain why rotating the coil produces an output voltage. So, due to magnetic fields, which is between the magnets from north to south, these field lines are being cut by the moving coil, which then induce EMF. Part 2. State the position of the retaining coil when the alternating output voltage is at a maximum value and explain why the maximum output occurs at this position. So whenever the plane of the coil is at its horizontal position, it's going to produce a maximum voltage. And why so? Because that's when most of the field lines are being cut by the coil at the highest rate. So when it is at its horizontal position, exactly like this, most of the field lines are being cut by the coil. Part B. A lamp and an open switch are connected in series to the output terminals of the AC generator. The switch is closed and the lamp lights up. The student has to apply a greater force on the handle. Explain why a greater force is needed to keep the lamp lit. So there is current in coil, and the coil experiences a force due to the motor effect, and that is due to the presence of the field lines and the moving coil carrying a current. And when a student applies force on the hand handle, he will be opposed by the force which is produced due to the motor effect, so he has to put a greater force. So there is current in the coil which experience a force due to the motor effect. So the force which is being exerted by the student will be opposed by this force, so he has to put a greater force. His exerted force will be opposed by the force due to the motor effect. Thus, he has to put a greater force to oppose the change, producing it. Question number 9, part A. Figure 9.1 shows a beam of alpha particles moving towards the thin sheet of gold in a vacuum. Detectors in the region surrounding the thin gold sheet detect the alpha particles and determine the number of particles that travel in various directions. State and explain what can be deduced from the following observations. Part 1. The majority of alpha particles pass through the gold sheet undeflected and are detected on the far side. This is the beam of the alpha particle, thin gold sheet, and this is the detector. They're saying that majority of alpha particles will pass straight without being deflected. And what do we deduce by this statement? That nucleus is of very small size. Most of the space around nucleus is vacuum. Nucleus is of very small size. And explanation to this statement is very few alpha particles hit the nucleus, because it says majority of alpha particles, mean nucleus is that much small that very few alpha particles will be hitting it, and most of passing straight without being undeflected by the nucleus. Part 2, a small number of alpha particles are deflected as they pass through the gold sheet, and the deduction is, why are they being deflected? Why don't they pass straight? Because nucleus is positively charged, and so are the alpha particles. Nucleus of the gold sheet is positively charged, and the explanation to it is alpha particles experience a repulsive force because like charges will repel each other. Part 3, a very small number of alpha particles are deflected through very large angles or returned back the way they came. So what do we deduce by this statement? That center of atom or nucleus is concentrated with its charge. Means most of the charge of the atom is concentrated into an atom's nucleus, and the explanation to it is nucleus is heavy, thus it stays still. In fact, it is making others deflect. Part B, a beam that consists of both alpha particles and beta particles is passed through a region of space where there is a magnetic field perpendicular to the direction of the beam. State 2 ways in which the deflection of the alpha particles differs from that of the beta particles. Okay, so as you know, the alpha particles, they contain 2 neutrons, 2 protons, and 2 electrons, while beta particles is just one electron. You know, electron is much lighter than a proton or a neutron. So alpha particles are very heavy in nature as compared to beta particles, and because both of them carry opposite charges, alpha particles contain protons while beta particles contain electrons, so they are going to move in opposite directions. So alpha particles will be deflected in opposite direction first, and due to alpha particles' higher mass as compared to beta particles, it is deflected much less than the lighter beta particles. So it is deflected less than lighter beta particles. So this concludes our today's video. Thank you for watching.